In this video, we're going to define what a method is, and we're going to look at the different parts of a method so that we can start to understand how to construct one. So what is a method? A method is a collection of statements that are grouped together to perform an operation. And I would like to add the word a single operation there, because if your program's designed well, each of your methods performs a single operation of some kind. I always tell people, if you tell me what your method does and you have to use the word and to tell me that it does more than one thing, then your method should probably be split apart into two different methods. Okay, so once our method is defined, and we're going to use this method called max here. This is the method called max. It requires us to pass two numbers to it, and it gives us an answer back. And we can call that method anytime we want by saying max and passing arguments to our method. So let's get into the details about what all these different parts of this method are for and what they mean. So a method is a collection of statements that are grouped together to perform an operation, and it has different parts. The top line here is called the method header, and it's followed by the method body that is located between two curly braces. So it's a block of code, just like we've seen a block of code with if statements. We've seen blocks of code with loops. A method also will have a block of code that determines where the method begins and where the method ends after the header. The method signature is a combination of the method name and the parameter list. So sometimes you hear people say that the entire thing is the method signature. I don't mind it when people confuse that term, but technically this author is just defining the method signature as the method name. So in this case, the method is called max, followed by its parameter list. Okay, so this method has a parameter list that takes two parameters. The first one is an int that's going to be called number 1. And the second one is an int that's going to be called number 2. So the method signature is the name, followed by the parameter list. And remember, the parameter list is inside parentheses. Sometimes those parentheses are empty because the method doesn't require any parameters. But usually we're going to see something in there. So the variables defined in the method header, this number 1 and number 2, are known as the formal parameters. Normally people will just say the word parameter. The book here is drawing a distinction between formal parameters and arguments, but most people use the term parameter for parameters and arguments for arguments. We'll see that in the upcoming slide. So these are the things that we are required, the information that we are required. If we want to use this method, we are required to give it information to store into those parameters so that the method can operate. So when I call the max method, I have to supply it with an int separated by a comma followed by another int. And you can see that over here. When I call max, I have to pass in this case, they're passing in x and y. Those are the arguments. They call them actual parameters. So the book calls them formal parameters and actual parameters, but in general, most people refer to these as parameters. And when you call it, these are the arguments, okay, rather than formal parameters and actual parameters. When a method's invoked, we pass a value to the parameter. That's called the argument. I just went over that. Didn't realize there was another slide because I was going to explain it coming up. A method might return a value. So the parameters are where we pass information into a method that the method requires to run. The return type comes right before the method name, and it tells us what kind of information the method is going to give back to us. So in this case, this max method requires us to give it 2 integers, and as a result, and for its result, it's going to give us back a single integer. Okay, so its return value type is integer. Sometimes you'll see the keyword void there. And if void is the return type, that means that the method is going to perform some operation, but it's not going to give us any information back once it's completed. All right, the entire, in front of the return type, you can also see modifiers. Usually you'll see public for a method. Technically not always, but almost most times, especially starting out in programming, you will see a public. And public just determines who's allowed to use this method. What other pieces of code are allowed to call this method? If it's public, any piece of code anywhere in your program can call it. Other classes can call this method. If it's private, it means only this class can use this method. But you won't see that with methods very often. You see that more with fields. You might also see a modifier that says static here. It may or may not be there depending on where this method is located and how it's being called. So if you think back to creating a scanner, before we could use a scanner, we had to create a scanner object with the new keyword. And then we could use the name of the scanner to call its methods. So if we called the scanner input, we could say input.nextInt. If you think about the math class, we might have called like math.pow. And we didn't have to create a math object first and give it a name. We just used the name of the class math. That's because the methods in the math class are static. So static means I can use this method without creating an object of the class first. Okay. And we'll see some distinctions of that as we get further along. Below the method header, the entire thing here is called the method header. So this is the method signature. We can add a return type in front and some modifiers, and the entire thing gets called the method header. Sometimes you hear people call the entire thing the method signature. That's not such a big deal. So those are all the parts of a method, and I know that's a lot. So let's go create a method ourselves using the problem that we started with in the previous video, and we'll modify that and we'll add these different parts and create our own method. It'll help us understand the more concrete implementation of what we just saw with a bunch of vocabulary.